Welcome back to Geo News Radio. We like to do these deep dives into some of the most exciting research. And today we're tackling a study that really caught my eye. It's all about using AI to uncover Phi polymetallic deposits.
Yeah, it's a really hot topic right now, especially with the demand for metals just skyrocketing.
Absolutely. And this study, it's in the January 2025 issue of Geology. You know the one.
Oh, yeah, I saw that one.
Title is a mouthful, though. A novel data knowledge dual-driven model coupling artificial intelligence with a mineral systems approach for mineral prospectivity mapping.
Catchy, yeah.
Well, what really grabbed me is how they're using AI and kind of like weaving in traditional geological knowledge to, make exploration more targeted.
It's a really neat approach.
So for this deep dive, we're going to unpack how this whole method works and why it's such a big deal for mineral exploration, what the future holds.
Sounds good.
Okay, let's set the stage. This study zeroes in on southwestern Fujian Province in China.
Oh, yeah.
They've got a history of Phi polymetallic production there.
Right. Geologically, it's a fascinating area.
Oh, how so?
Well, it's near the suture of the Yangtze and Cathaysia blocks.
Ah, yeah.
So you've got these massive tectonic plates colliding, creating like the perfect setup for these types of deposits.
Wow. And this study specifically focuses on stratabound skarn-type Phi deposits.
Most common type there.
Now, just as a refresher for our listeners, skarn deposits form when you have these hot mineral-rich fluids interacting with rocks.
Exactly.
Which often leads to, a good concentration of valuable metals.
It's like nature's way of concentrating metals into these economically viable deposits.
But even when you know the geology, finding those deposits is still tough.
Oh, for sure.
That's where the mineral systems approach comes in, right?
Right.
It's like detective work, tracing the journey of metals from their source to the deposit.
Yeah, instead of just looking for the deposit itself,
Yeah.
we try to understand the whole process that formed it.
Makes sense.
Yeah.
So what's the story for these Phi polymetallic deposits? Where's all that iron coming from?
Well, the prime suspect is these Janshanian granitoids.
Okay.
Large igneous intrusions you find all over the region.
Uh-huh.
And they're thought to provide the heat, the fluids, and a good chunk of the iron needed to form those deposits.
Oh, wow.
And, if you look at a map, it's pretty clear there's a spatial connection.
Like a pattern.
Yeah. Known Phi deposits tend to cluster around these granitoids.
So these granitoids are like these massive iron reservoirs.
Yeah.
Just waiting to be tapped.
Exactly.
But the iron doesn't just magically appear in a deposit, right?
Yeah.
How does it travel from those deep sources to shallower depths where we actually find them?
Well, think of faults, those fractures in the Earth's crust, as like a network of underground highways.
Okay, I'm listening.
Allowing these mineral-rich fluids to flow through.
Like a plumbing system for a mineral deposit.
Exactly. And in this region, you've got major fault systems like the Zhangde-Dapu, the Shanghang-Yungshao, and the Ninghuanan-Ping faults.
Wow, that's a mouthful.
They not only shaped the geology, but also provided pathways for those fluids to move.
Oh, so it's not just about the iron. It's about how it gets around.
Exactly.
So these fluids are flowing through these faults, picking up iron from the granitoids? Anything else contributing to the mix?
It's likely the fluids didn't just carry iron from the granitoids. They probably picked up even more iron from the surrounding rocks as they flowed.
Interesting.
And seismic activity could have also played a role. Picture earthquakes squeezing those fluids through cracks, enhancing the metal enrichment process.
So it's like this dynamic system with all these factors contributing to concentrating the iron in these fluids.
Exactly.
But at some point, all that iron needs to settle out of those fluids to form a deposit.
Right. That's where you need that sweet spot.
The Goldilocks zone.
The perfect conditions for mineral deposition.
Like the right temperature, pressure, the presence of specific rocks.
Precisely.
So what's the Goldilocks zone in this case?
Well, it seems like the Carboniferous Permian carbonate rocks provide those ideal conditions.
Okay.
These carbonate rocks, rich in calcium, they react with those iron-rich fluids.
And that leads to the formation of skarns, those mineralized zones.
So the fluids flow through the faults, hit these carbonate rocks, and boom, conditions are just right for the iron to precipitate out.
Yeah.
Forming in V polymetallic deposit?
Exactly.
Makes sense that the deposits would form where those key ingredients come together.
Right. And as you might expect, most of the known Phi deposits in this region are found either within these Carboniferous Permian formations or right at that contact zone between the carbonates and the granitoids.
It all comes together.
It does.
But finding a deposit is only half the battle, right?
Oh, yeah.
It also has to survive millions of years of erosion and other geological processes.
Absolutely. We call that deposit preservation.
Right.
And in this region, there's evidence of major denudation events, periods of intense erosion
Yeah.
that could really impacted the preservation of these deposits.
I mean, millions of years of geological processes, right?
Long time.
That can mean the difference between a multi-million-dollar deposit and nothing. Exactly. Think about events around 110 to 85 million years ago and 40 to 25 million years ago.
Wow.
That likely reshaped the landscape.
It's mind-blowing to think about those timescales and how they shape what we have access to today.
Yeah, it's incredible.
So we've got the geological backstory, the iron source, the transportation system, the deposition zone, and the whole preservation thing. But where does AI fit into all of this?
Well, that's where things get really interesting. This study takes a data-driven and knowledge-driven approach.
Data-driven and knowledge-driven. Explain that.
Okay, so they started with a ton of geological data. Geological maps, geochemical data from rock samples, geophysical data like magnetic readings, even digital elevation models.
So every piece of information they could get their hands on.
Exactly, a treasure trove of data.
But how do you even begin to make sense of all that? That's where the AI comes in, right?
Right, they transform each type of data into maps, creating a visual representation of potential mineral zones.
So instead of just staring at numbers on a spreadsheet, they're looking for patterns and anomalies on a map.
Precisely. And to analyze these patterns, they used Graph Convolutional Neural Networks, or GCNs.
GCNs sound pretty complicated.
They are, but think of them as like pattern recognition machines on steroids.
Okay.
They sift through this mountain of data and find hidden connections between, say, the location of faults, the types of rock present, and the likelihood of finding a deposit.
Connections that would take us humans forever to figure out.
Yeah, exactly.
It's like giving geologists a superpower.
Right.
Letting them see patterns they might otherwise miss.
And what's even cooler is they didn't stop there. They incorporated geological knowledge into the model.
Okay.
They created what they call geologically constrained layers.
What are those?
They're basically mathematical formulas representing known relationships between geology and deposit formation.
So they're not just letting the AI run wild with the data. They're giving it some expert guidance.
Exactly. Like saying, hey, AI, pay attention to these features. They're the ones that matter.
That makes sense.
This guidance helps the AI focus on the most promising areas, making its predictions even more accurate.
It's like combining the power of AI with the wisdom of experienced geologists.
Exactly.
So we've got the data, the AI, the geological expertise, all woven together. But did it actually work? Did this model manage to pinpoint those hidden fee polymetallic deposits?
The results are pretty impressive. The model pointed to several areas with high potential for mineralization, places that might have been overlooked using traditional methods.
So the AI is basically saying, hey, go check out these spots. You might find something valuable here.
That's the idea. It's able to pick up on subtle patterns and relationships in the data that we as humans might miss.
Like what kind of patterns?
Well, for example, it might find a correlation between a specific type of fault and the occurrence of fee deposits.
So it's not just about finding iron in a rock sample. It's about understanding how all these geological factors work together, the faults, the intrusions, the rock types, to create those perfect conditions for deposit formation.
Exactly. The AI can see the big picture, connecting the dots in a way that would be really tough for us to do manually.
It's like having this incredible tool that can see things we can't.
And what's encouraging is that many of these high potential areas identified by the AI actually line up with known fey deposits.
So the model's predictions are matching up with what we already know about the geology of the region.
Right. It's not just making things up.
But couldn't that just be a coincidence? Is there a way to be sure the model isn't just picking up random noise in the data?
That's a good question. To test that, they use something called success rate curves.
Okay.
Basically, it measures how well the model's predictions line up with the actual distribution of deposits.
Like a scorecard for the AI.
Exactly how many points can it score by correctly identifying those mineral hotspots?
So how'd it do?
Remarkably well. The study found that about 20% of the study area encompasses all the known fey deposits.
Hold on. So the model is saying that 80% of the region is unlikely to have these types of deposits.
That's right.
That's huge for exploration companies.
Absolutely.
It's like a roadmap telling them, focus your efforts here. This is where you're most likely to strike gold.
It lets them narrow down their search area, potentially saving time, money, and resources.
And reducing the environmental impact of exploration.
Exactly, a win-win for everyone.
But this seems bigger than just iron deposits. Could this approach be used for other minerals too?
Absolutely. This kind of AI-driven approach could revolutionize how we explore for all sorts of minerals. Copper, gold, even those rare earth elements that are so important these days.
It's like opening up a whole new world of possibilities.
Exactly. We could find resources we didn't even know existed or access resources we thought were impossible to reach.
It's really exciting. But before we get too carried away, what are some of the challenges? Are there any potential pitfalls with this AI-driven approach?
Well, like with any technology, there are limitations.
What kind of limitation?
One of the biggest is data quality. AI models are only as good as the data they're trained on.
So garbage in, garbage out.
Pretty much. If the data is incomplete, inaccurate, or biased, the model's predictions will be off.
So it's not just about throwing AI at the problem. We need to make sure we're giving it the right information.
Exactly. Data quality is key. And then there's the question of geological expertise.
Yeah. Some people might think this means geologists will be out of a job, replaced by robots.
I don't think so. AI is a powerful tool, but it can't replace human ingenuity and experience.
So it's more about humans and machines working together.
Exactly. The AI can do the heavy lifting with data analysis. But it takes a skilled geologist to interpret those results, to understand the nuances of the geology, and make the decisions about where to explore.
So it's a partnership. The AI provides insights, and geologists provide the experience and judgment.
A good way to put it, the AI helps us see things we might miss, but it's still up to us to make sense of those findings and use them in the real world.
Okay, so we've talked about the potential, the challenges, the need for collaboration. Where do we go from here? What's next for this AI-driven exploration revolution?
I think we'll see a lot more research exploring new AI techniques, refining existing models, and applying this technology to different types of deposits and geological settings.
It feels like we're just getting started.
Absolutely. And I'm excited to see what the future holds.
Me too.
Yeah.
It feels like we're on the verge of a new era in mineral exploration, one where AI helps us unlock the Earth's hidden treasures in a smarter, more efficient, and more sustainable way. We've really gone deep on this one, haven't we? AI in mineral exploration. It's a game changer.
It really is.
From the geology of southwestern Fujian Province to those sophisticated AI models, it's clear that something big is happening.
No doubt.
But let's zoom out for a second. Why should someone who's not a geologist care about all this?
That's a great question.
What does this research really mean for the average person?
Well, this study marks a major shift in how we approach mineral exploration.
Okay.
For years, we've relied on traditional methods, geological mapping, geochemical sampling, geophysical surveys.
The tried and true.
Yeah, but they can be time-consuming, expensive, and sometimes they just don't cut it.
Especially now. With the world needing more and more metals, finding new ways to explore is critical.
Exactly. That's where AI comes in. It can make explorations so much more efficient and effective.
How so?
It can analyze tons of data, identify patterns, make predictions with an accuracy we could only dream of before.
It's like having a whole team of geologists working around the clock.
That's a good analogy.
And what I find really interesting is that we're not just throwing data at the AI, we're incorporating geological knowledge into these models.
That's key.
So it's not about replacing geologists with machines.
Not at all.
It's about giving geologists a new tool.
Exactly. This blend of data analysis and expert knowledge is what makes it so powerful. AI can enhance what we do, help us see things we might miss.
But in the end, it's still up to geologists to make those calls.
Right, to interpret the results and make the decisions.
It's a collaboration. AI providing insights and geologists providing the experience and judgment.
A true partnership.
So why should someone who's not a geologist care?
Because this has implications that go way beyond the lab or the field.
You're talking real-world impact.
Exactly. This technology can change how we find and extract the resources that power our world.
Our phones, our cars, our buildings, everything relies on these materials.
Right, and as demand grows, finding new sustainable ways to locate and extract them will only become more important.
So AI could be the key to meeting that demand responsibly.
Exactly. By making exploration more efficient and targeted, we can minimize environmental impact and ensure we're using resources wisely for both us and future generations.
Finding that balance between technology and responsibility.
It's essential.
Well said. It's not just about the science. It's about using it to tackle the challenges we face.
I agree.
So for those who want to dive deeper into this research, where can they find the study?
It's in the January 2025 issue of Geology.
Yeah, that title, though.
A novel, data-knowledge, dual-driven model coupling artificial intelligence with a mineral systems approach for mineral prospectivity mapping.
You got it. Well, this has been an incredible deep dive into the world of AI-driven exploration. Really makes you think about what the future holds. And for our listeners, remember to subscribe to Geo News Radio on Spotify, produced by PGO Ricardo Vales, president of Vales Geoconsultant, for more deep dives into the fascinating world of geology.
Thanks for tuning in.
And keep exploring.
My name is Ricardo Valls. I am a professional geologist registered in the province of Ontario, Canada, and also the president of Valls Geoconsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 550 videos.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.